Anybody want to guess how old that picture is? It's like, oh, thank you, Dimitri. Yeah, it's like, yeah. David here actually guessed. I think yesterday 10 years. It's 10 years old. So yeah, good guess. So my name is Mark. I work as an engineer at Miston Labs on Sui Core. I'm going to be talking about Sui local fee markets. So last year in Paris, I gave a talk about our congestion control system. It was a much more mechanical discussion about how things actually work. So if this is all new to you, you could consider going back and watching that talk. Yeah, I always plug my past talks whenever I get on stage. But that'll give you kind of the background for how things work under the hood. This talk's going to be a little bit more high level, talking about what local fee markets are and why they exist and how they're going to help you on Sui, either as a user or as a builder. Okay, so I want to just do a very quick review of the object model of Sui. And this might be old news to a lot of you, but if you're new to Sui, it's very important to understand this. This is really how Sui scales. So unlike on many other blockchains, objects rather than accounts are the fundamental units of data. And so transactions on Sui, they consume objects and produce new objects. So if you want to kind of get the simplest possible image in your head of what a transaction is doing, it's taking an object at one version, which is this circle on the left, consumes it, does some computation, and spits out a new version of that object. And this is what really is behind the scalability of Sui, because if transactions operate on objects, then when you have many transactions which are operating on disjoint sets of objects, you have a very easy to parallelize system. And so right now we're able to parallelize across many cores on a single machine. And in the future, as Sui grows, we can split this across multiple machines and theoretically scale up to very, very high rates of traffic. And of course, transactions don't consume only one object. They can consume many objects. I made the picture here very simple, but I'll come back to that in a minute. Now, one implication of this model, well, and it's not really an implication of this model, it's just sort of a fundamental fact of the universe, is that when you have a sequence of transactions that are operating on the same state, you're not going to be able to parallelize it. So we have one object here, which a steady stream of transactions are coming in, updating the state of that object, and this produces just a serial execution path that can't be parallelized. Throughput is limited. And when throughput is limited, how do we cope with that? What if there are more people sending transactions that want to use this object than we can actually service? Well, what we have to do is some of the transactions get canceled. So, and this was the subject of my talk last year, was basically how do we manage to do this? How do we find out how much work can we do and what happens to additional work that is in excess of what we can handle within a given period of time. So this gray transaction, or I guess it looks kind of green here. The transactions at the end that have been grayed out, those have been canceled. The submitter of those has gotten an error message I'll show you in a second, saying system is too congested. You can't use this object right now. And what does that look like? If you use Sui Vision, you might have, if this happened to you, you might have seen this. I know it's a very small, hard to read. So you get this error that says execution canceled due to shared object congestion. And it gives you a list of objects that have been, that were congested and which caused your transaction to fail. Has anybody had this happen to them? Show of hands. Dimitri, okay. Just congesting, yo. Yeah, Dimitri's causing the congestion, okay. Yeah, just a quick zoom in on that. Okay, so the most important thing about this is which transactions are getting canceled and how do we determine that? So I'll walk you through this step by step. So the way that Sui schedules transactions which are touching shared objects is we have, you'll actually hear more about maybe the more detailed mechanics of this in the next talk, but our consensus system produces what we call commits. A commit is a batch of transactions that have been proposed by various validators and are now being committed at the same time. And these commits happen about 14 times per second right now, so this is a pretty high frequency process. In each commit, we get a batch of transactions, and we sort them by the gas price. If you're not familiar with gas price, this is basically a parameter that you set on your transaction that determines the relative cost of the transaction. So if you have, for sending a basic transaction where you're just transferring an object, you'll use what's called the reference gas price. So this is, I forget, it's somewhere between 750 and 1,000 right now. I don't know exactly what it is, but that's sort of the lowest level gas price that you can pay to have a transaction executed at all. But you can set your gas price higher, and as you set it higher, it's effectively a multiplier on the cost of your transaction. So if you set it to 2 times the reference gas price, your transaction is going to be twice as expensive as it needs to be. And so this is a very natural way to bid within the system for priority. Because you're effectively saying, my transaction is so valuable to me that I'll pay 2 times or 5 times or 100 times the base cost in order to have it executed. So this is a little different than, I think like a lot of other blockchains, people are used to using tips. And there may be a role in Sui for tips in the future where you just have a direct transfer to a validator. There's a number of situations where this might come up. But for now, for congestion control, the gas price is really the thing that matters. So higher gas price transactions get scheduled first, and we simply go through this ordered list of transactions and measure how long we think they're going to take. And that's a much more detailed topic that I'm not going to get into today. But we decide how long these transactions are going to take to execute, and when we have reached the maximum amount of work that we're willing to do in that commit, then everything after that point either gets deferred, and it might be considered the next commit, or it'll get canceled if it's already been deferred for too long. Deferral might go away, but you probably don't need to worry too much about it unless, if you have like really detailed questions about that, find me later. All right, so what do we, given this sort of basic mechanism of taking these transactions, ordering them, canceling extra ones, what do we mean by local fee markets? So what we mean by local fee markets is this idea that on Sui, you have many distinct objects, and they don't interfere with each other. So if you have a very congested object that's very difficult to schedule transactions on, people might have to bid a lot to run a transaction on that object, but it's not going to affect other apps. Everything is isolated for the most part until like the whole system reaches its capacity. But assuming there's capacity left in the system, then transactions on different objects don't impact each other. So that means that if you are playing a game where you're trying to trade, some virtual good to somebody else, and meanwhile there's this massive congestion going on because there's all these price swings in some, DeFi market, it doesn't matter. You'll be able to do your the game can have very low latency, no congestion, no excess fees. And really the core thing about this, the core thing that local really means here is that the network fees as a whole do not scale. You're not paying more to use Sui because of congestion. You might be paying more to use a particular resource that is on Sui, right? And it's an important distinction because we want the network to be able to handle many different applications at once, and many of these applications shouldn't even know that that the other ones exist, right? Okay, so as I said earlier, we use gas price to order transactions. Higher price transactions go first, and gas price is a multiplier on the cost of the transaction. Now, there are 2 different cases that we see right now for why you would want to be bidding a higher amount of gas, and they have slightly different implications. There's really 2 things, and I call them inclusion and priority. And broadly, the way that I would say to think about these is that if you're bidding for inclusion, then what you really care about is my transaction is going to get executed soon in a timely fashion, like within a second or 2, right? If you're bidding for priority, what you're really bidding for there is I want to be the first one among everybody else to access this object. Priority really comes up more in MEV use cases. Inclusion is more of an application thing, or users generally will care more about inclusion unless they're MEV searchers. So an example of an inclusion bid is there's a congested pool. Like so Deepbook, for instance, has effectively a different object for every currency pair that it trades, and so those objects can become congested. But in most cases, if you want to swap, say, Sui for USDC, you mainly care about, are you going to get executed relatively quickly? However, if you are a searcher, then what you are probably trying to do is you're looking for arbitrage opportunities, and you are submitting, and when you submit that transaction, you assume there's other people searching for the same thing. You want to be before them, because the first one is going to take all the profit from that arbitrage. Everybody else gets nothing. And the transaction may actually be worthless if it's not the first. So how do you bid in these two different cases? So for inclusion bidding, what you really need to know is what is the clearing price of the object. Like for a given object, at what price level will I actually be scheduled instead of canceled? For priority bidding, it's very different. Typically in these cases, there is a profit opportunity on chain, and so what you are bidding is the value of the opportunity. And the key difference between these two cases is that with inclusion bidding, the network, we can help you figure out what you should bid. And I'll talk a little bit in a second about how that works. For priority bidding, it is really for the end user to decide, like, what is the value of this opportunity? How much should I bid in order to make it worthwhile? Obviously, you don't want to bid so much that your transaction costs more than the profit that you end up taking. One other thing to discuss briefly regarding inclusion bidding is SIP45. Has anybody here heard of SIP45? Yeah. Okay. Has anybody not at Miston, not a Miston employee, heard of SIP45? Okay. A couple. Okay. A couple. That's good. Okay. So SIP45 was basically an improvement that was proposed by Shio, one of the big searchers on Sui today, and also they also operate a matching auction for DeFi use cases. The basic idea behind this was that first it drastically raised the cap on our gas price because we previously had a max gas price that was quite low. And it also included some essentially hacks that helped a high gas price transaction get into the earliest consensus commit possible. Before this, if you had multiple searchers trying to take the same arbitrage, sometimes they would just randomly be placed into different commits just due to timing jitter. And so in that case, there is no point for either of them to bid anything because it's a lottery, basically, who gets that. And so the goal of SIP45 was fundamentally to help the validators and the stakers share in more of those MEV profits. So rather than having a lottery where one of a couple different searchers just gets all the profit, we want them to bid against each other, and the proceeds from those bids get redistributed to the network. I'll briefly say a few words about the state of congestion on Sui today. So we mainly see it on a few high-value objects. The Deepbook Sui USDC pool sees congestion sometimes. The Sui system object sees congestion. The good news is we have an improvement to the congestion control system coming soon, which is going to drastically increase the throughput possible. Right now, we are basically conservatively scheduling, and so we're scheduling much less work than we actually could in many cases. So this is intended to just take full advantage of how much we can schedule. And we're hoping to see hundreds of transactions per second on a single Deepbook pool. Will hopefully be we'll see. That's the goal, though. And so once this launches, we hope that for a while, at least, there will essentially be no congestion on Sui. And so most of the bidding will be in the form of priority bidding. But we also hope Sui grows and we do see congestion soon. But I do want to emphasize that our goal, like on the engineering team, is we need both of these things. But what I really prefer to focus on when possible is making our throughput as high as possible and giving as much access to these valuable objects as possible. And there's many different things that are going on behind the scenes to make that possible right now. Okay, so if you have seen this error in the past, what can you do to improve? How can you cope with it better? Well, you should know that if you're using multiple shared objects, you're going to have to bid on the most congested object. You can use explorers to help figure out how expensive those objects are. And in the near future, the dry exec transaction block API will be able to return a suggested price to you, saying this is the price that we think you should bid if you want to be scheduled. Some other implications of this, DEX routers may need to take congestion prices into account for cost effectiveness. If you have to pay a high bid, a high gas price bid in order to go through a certain route, it may eat up some of the savings of using that route. Yeah, I think users in general, like retail users, are not going to be super aware of what's going on with this. I think it's a lot to ask of them. So DApp builders, you may want to consider trying to take this into account, suggesting gas prices to the users. And also, if you are writing move code, optimizing your move code will actually make things cheaper even in the presence of congestion. All right, so I mentioned this stuff already. And I'll very briefly, I'm out of time, so very briefly, just a couple things that we're thinking about for the future. We want to start thinking about custom ordering rules for packages, because one of the things that is very commonly requested on DeFi is the ability to have cancels go before trades. But you don't want to have people to pay a lot to do the cancel. Similarly, we might want Oracle updates going before Oracle reads. Yeah, and so on. So if there's things in this area that you're concerned about and that you want to see, find me later, talk to me about it. And thank you very much.